Welcome back. Previously we discussed parabolas and ellipses and what the definitions were and what that looked like graphically to put them out there. In this video we're going to go over hyperbolas. So again, we're going to go to our study guide or our memorize page, and we see our hyperbola formulas and vocabulary. We're going to be doing an open and left one again. To do the other one, just affect the x or the y depending on which one we did. So in this one, foci is affecting the h, and this one would be affecting the k. So x minus h squared over a squared minus y minus k squared over b squared equals 1. And we're opening, so if we go back and see, we're opening left or right based on where we're putting this information. So let's draw this. We're going to put it slightly off center. Okay. So our center is still going to be HK. In this case, it's not actually part of it, just kind of like ellipses. It's not actually on the edge. So that's going to be our center. We're going to find that as HK. And just like in the other videos, we do just regular transformations. H, value, K, up. Next, we're going to take a look at the major and, well, there's not really a minor axis, but you'll understand what we're trying to get at with that in a minute. So if we look at our major axis, so that's going across here, it's also known as our focal axis. That is going to be y equals k, right? Y is constant. We're not moving up or down any. And then our vertex is going to be a away, so that is exactly the same as we're used to. So these would be our vertices. And that's going to be h plus or minus a, k, because we have to move both directions from the center. We can then look at our, so the way they define these axes is no longer the major and minor. They call it the semi-transverse and the semi-conjugate, or the conjugate and the transverse axis. So the transverse axis is going to be 2a, and then the semi would be a, and then the semi-conjugate, or I'm sorry, the conjugate axis is 2b. And then, like I said, the semi-transverse would be a, the semi-conjugate would be b. We've already defined that our vertices are going to be an a distance away. Our vertex, or I'm sorry, our foci is going to be as always, on the inside of our curve. So unlike ellipses, it's further away than the vertices. So keep that in mind. Our foci is going to be h plus or minus c k, right? Because we're not moving up or down any, so it would be the same as the center. Our b then, so let's define this. We've got a here, c here, and this imaginary point here that b is going to, we create our Pythagorean identity, or Pythagorean situation again. So this distance to the vertices was a, the distance up is b, and this distance is going to be c. So the distance in a hyperbola from the center to the foci is the same as from the major vertices to what would have been our minor vertices, if you want to call it that. And we'll see kind of what b actually does in a minute. But we would have the situation as vertex, center, and then we're just going to call this B points. And then this distance is A, this distance is B, this distance is C. So if we're trying to find the distance to the foci, A squared plus B squared equals C squared, square root of A squared plus B squared is C. So depending on what values you have, obviously you may be doing this differently, but for our purposes, I was assuming that we had this information and we were drawing it. So in the base standard formula, we do not get the value C. So what B and A actually are doing is they are creating this imaginary rectangle around here. And B is obviously that distance down too, so this is also B. And the point of it is, these corners are creating our asymptotes for our hyperbola. So if I drew, I mean it's obviously not to scale, but if I drew this through the corners, I create the asymptotes. So that is what B and A are creating, this little rectangle right here. The actual formulas for the rectangle in this case would be y equals plus or minus B over A, x minus h plus k. Most of the stuff we look at is intuitive into how it works. The A was the distance to our vertex, the C was the distance to our foci, that was the same as ellipse. This one is a little odd with what B is doing, but we have seen that the 2A creates this axis, the major axis, in this case the focal axis, and B would create the minor. So even though we don't actually have a point up here, it makes sense why that operates the way it does. The asymptotes are a little more complicated to understand. If you want to get into why that operates the way it does, please do and play around with it, but we can also just draw the asymptotes through the corners. And that is everything for hyperbolas. Thank you.